Hand deploying code and models won't cut it for long. Let's understand how we can build on DevOps and apply those lessons to machine learning. Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel. I'm the proprietor of Catalyxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. So far in this series, we've systematically built up skills in Azure Machine Learning, starting with automated machine learning, moving to point-and-click techniques, and finally, code-first machine learning development. This is a pretty natural progression, though we aren't done yet. The next step in our journey is to see how we can automate the training, testing, and deployment of machine learning models. As I am wont to do, we will take a slightly roundabout journey to get there. Let's start with a brief discourse on software development and deployment. Once you get beyond IT teams whose member roles you can count on one hand, you're likely to see separation of duties. Some people are responsible for writing code, some for testing code, some for managing the servers which host that code, that kind of thing. As organizations grow, we see deeper areas of specialization. But the point I'm driving home is that no single person controls the entire end-to-end process for code development and delivery. And experience tells us that this is a good thing on net, especially as the software you're developing becomes more important to end users. Having more eyes on a problem, particularly when you have people who have different areas of expertise, can uncover potential breaking issues before they arise in practice. Also, it becomes harder for a nefarious developer to introduce malicious code when more people are looking carefully at the code and thinking about the deployment process. But with specialization comes a new series of problems: information gaps. The software developers know how their code works, hypothetically at least, but operations people typically don't have that detailed knowledge. Therefore, when the development team dumps an archive file with all of their code artifacts into the hands of release administrators, we can easily end up in a situation in which the person releasing the code makes a mistake due to a vague guidance from a developer or ambiguity in the release documentation. This idea of developers tossing their code over a wall like they're flinging dead cats into a despised neighbor's yard comes as a result of organizational dysfunction. Development and operations have natural friction points we have to consider. First, these teams tend to be under different leadership and might even have different chains of command up to the C-level. Second, the two groups tend to have different strategies and incentive structures. Developers want to, and get paid to, ship new code and push things as quickly as possible. Operations people want to minimize downtime and risk. They are the ones getting paged at 3 a.m. because the dumb service is failing yet again, after all. And so, these people typically want to minimize the shipment of new code. Over the years, we've come up with ideas to try to square this circle, and that leads us to our first major topic: DevOps. DevOps is a combination of people, practices, and tools. Sadly, for thus technically minded misanthropes, it turns out that tools are the least important part of the job. It's mostly about people and process. The real success of DevOps comes when you enable developers and operations teams to work together to achieve both sets of goals in as efficient a manner as possible. Let me give you a few examples of how. First, continuous integration and continuous deployment let developers ship frequently, maybe even dozens of times per day, but each deployment is small and runs through enough automated testing to reduce the risk of a major problem. Second, developers work with the operations teams to build the tooling that ops needs to find problems quickly. Developers need to think about how they can include instrumentation to ensure their code is working as expected or generate alerts when it isn't. This helps the operations teams by letting them see things go wrong and hopefully catch problems during the middle of the day when everyone's in the office, not 3 a.m. when those lazy developers are all drunk or asleep. The third example I want to use builds off of the second. In a pre-DevOps world, dev and ops teams had relatively few points of contact. Now, this certainly varies by organization, but there's usually no executive level or even managerial emphasis on having these groups work together. There are official points of contact, of course, but these tend to suffer from the flaws of bureaucracy. Everything must fit into the round hole. Unofficially, individual developers and individual administrators could cut out certain levels of red tape to get things done, but there's only so much you can do on that front. By contrast, this ideal notion of DevOps includes collaboration between the teams, explicit collaboration. That might mean putting them all in the same chain of command, or at least having them join up at a lower level. But it could be as simple as managers from these teams emphasizing coordination, finding more ways to get individuals talking to one another. This helps get the point across that it's not developers versus operations, it's developers and operations. So, okay, we've talked a lot about DevOps so far, but that's not where this story ends. DevOps is ultimately about shipping code and its related artifacts. The next challenge involves data, leading us to DataOps. DataOps is DevOps, but with one additional challenge: state. Deploying application code is relatively simple, as application code tends to be stateless, especially in this modern era of everything's web development. We can refresh a browser and the app starts us over, meaning that deployments have a minimal impact on users, if done right. By contrast, databases are all about state. Put in other terms, databases are where the developers dump all that icky stateful nonsense they want to avoid. As a result, we need to think not only about the database code, that is, definitions of things like tables, views, stored procedures, and functions, but also the current state of our systems. That database code is something we can easily store in source control. But what do we do about the data? Well, we can store some reference data in source control, as this is company controlled and doesn't frequently change. User data, on the other hand, is a real challenge. Now, I won't dive too much into the tooling and approaches for data ops, though I will probably have some videos on the topic someday in the future. Instead, I just want you thinking about the types of challenges which come up once you introduce data. And then, I want you to take a step further, because that's where we're going with MLOps. With DevOps, we cared about shipping code. With DataOps, we cared about shipping code and data. With MLOps, we care about shipping code, data, and models. This adds one more level of complexity to the process, but it's ultimately the same confluence of factors in the solution: people, process, tools. Here's a depiction of the data science lifecycle that I swiped from Microsoft. In it, we will see some of the same considerations that we would see with regular application development. Writing code, packaging that code, testing the code, deploying the code, monitoring the code. In this case, code is not just a series of Python scripts, but also serialized model artifacts and weights, and we need to track our testing and training and validation data somewhere along the way. Where this becomes a challenge is that there are even more teams which factor into MLOps. In addition to software development and operations teams, we typically also include data scientists and data engineers. This addition of relevant teams makes it all the more important that we have smooth cooperation across these parts of the organization, and we try to inculcate a culture of cooperation rather than blamestorming and jealous guarding of turf. To this end, I think it's worth discussing the MLOps maturity model. There are a couple of them that I like, one from Google, one from Microsoft. I'm going to focus on the Microsoft one because it has 5 levels and allows for a bit more nuance than the Google model. But this is certainly not the only way to think about how to solve problems in MLOps. We start off this maturity level at the bottom rung, level 0, where you have no MLOps at all. Before I talk about the properties of level 0, let me point out that this maturity model is more at the project level than at the company level. Within a company, you might have projects at different levels of maturity, though company-wide practices will help us determine how quickly you can move up from level 0, if you can at all. Anyhow, you can tell you're in level 0 because data scientists, data engineers, and software engineers, and I might add operations people as well, they're all running off on their own with little to no collaboration. Everybody's doing manual work to find the data, and data scientists are doing all the work on their laptops or their VMs without any semblance of source control or consistency. When the data scientists do get their work done, they drop model files on a shared drive and nobody else understands how these things work. Software engineers then spend a lot of time sitting with those data scientists to figure out how to incorporate that model, and everyone crosses their fingers the next time a model drops. This sounds somewhat bleak, but even just a few years ago, this was the norm for most organizations with data scientists. Now let's move to level 1 in this story. Level 1 introduces DevOps, but there's no MLOps yet. The people are still siloed, so nothing has changed there. In the model creation section, we can see that there are data pipelines to grab data automatically and make it available to the data scientists, but the work the data scientists are doing is still handcrafted on their custom machines. Model release is still quite similar to level 0, with release being a manual process and scoring happening, if at all, sometime after the experiments end. The difference is, here, data scientists hand off the model to software engineers rather than doing the release themselves. Then, in application integration, we see some of the practices behind DevOps, some level of unit and integration testing, as well as automated releases of code. But there's still a strong reliance on data scientists to put all the pieces together. Level 2 is where we start to see some of the benefits of MLOps. At this level, data scientists and data engineers are collaborating, and the data scientists are beginning to turn their handcrafted and custom code into repeatable scripts which can be executed as jobs. Software engineers are still in their own bubble, but at least we have some collaboration. On the model creation side, we're beginning to manage compute, meaning we have some consistency in data scientist environments and can build out new machines or Python virtual environments based on system requirements. We are also tracking experiments, allowing us to see the history of this particular model. One of the important things here is that training code and models are both version controlled, so we can go back in time and retrieve old training code or older versions of models for comparison. Data, however, is not version controlled yet. Actually, data is kind of not included very well in this MLOps maturity model, and I would put something like a level 2.5 where we really start to incorporate how we manage the data. But I'll have to save that for another day. In the model release section, we're still seeing manual releases, but at least the scoring scripts are included with the model in version control. Software engineering is responsible for this release. The application integration side hasn't really changed at this level at all. Moving on to level 3, we finally see all three groups collaborating to some extent. Data scientists work with data engineers, and data engineers work with both data scientists and software engineers, meaning software engineers work with data engineers, but data scientists are not yet collaborating closely with the software engineers. Because we've implemented automatic training, the model creation process is already in pretty good shape. Model release, however, is the focus for this level. We have the automatic release of new models, and we can do that because each new model has its scoring script associated, and we're using a continuous integration, continuous delivery tool like Azure DevOps or GitHub Actions to push the new models out. When it comes to application integration, we have spent even more time writing tests to ensure that new releases maintain all of the necessary functionality and they don't break the app. By this point, we're taking that data scientist expertise and codifying it in tests. Level 4 is the final state, and it's a good one. Data scientists, data engineers, and software engineers are all collaborating with each other and filling in the gaps of knowledge between groups. On the model creation side, we see one new addition. Retraining is triggered automatically based on production metrics that the software engineers help put in place. Here are two brief examples. First, we might retrain if we see data drift. That is, if the distribution of our input data differs considerably from our training data. Second, if we see the accuracy of our models going down over time, we can schedule retraining and see if new data helps improve that accuracy. The model release and application integration sections remain the same, but taking a quick look at this, if you get to level 4, you have the entire team working together to solve complex problems and ship code without any sort of manual deployment or testing. Even projects in level 4 still have manual processes and human-led troubleshooting, but a large percentage of the tedious manual effort goes away by this point. I won't sugarcoat things and say that level 4 is easy to get to. Most of the projects I've worked on hit level 2 or level 3, and it took several years of concerted effort by talented people to get some of our last projects up to level 4. But it is possible, and I think that having the end result in mind does help focus the mind on what you need to move up that ladder. We've spent a lot of time talking about the idea of MLOps and what it looks like as an organization matures its stance on the topic. In the next video, we are going to get an idea of how we can incorporate some of the tooling around MLOps, applying it to our Chicago parking tickets example. We'll have links and show notes in the description below. And until we see each other in the next video, take care.